Hey there, everyone. In today's lecture, I'm going to show you how to create a Python to SQL converter. Basically, we're going to use Python code to create some SQL code and do some transactions on a SQL Server database. So it's fairly straightforward to create Python code that creates SQL code and interact with some type of database, whether it's SQL Server, MongoDB, any kind of AWS database, Microsoft Azure, GCP databases, BigQuery, things like that. So that's pretty straightforward. I'm going to show you SQL Server because that's what I have access to. Otherwise, I would create some videos around that. So you've got to use what you have, right? And what I have is SQL Server. So if you do a quick Google search, you can find SQL Server Express. Here is the link. I put that in the link. I put that link over here in the bottom of my Jupyter notebook. If I scroll down to the bottom, you'll see the URL right there. So that's where you can go to get a fresh copy of SQL Server Express, totally free, pretty easy to download and install. And if you don't have the link for whatever reason, or you forget about it, just go to Google, okay, SQL download, SQL Server Express, and click on the first link, probably the first, maybe the second, use your intuition. Okay, look for SQL Server Express. That is right here. And I accidentally just downloaded it. I thought I was just going to highlight it. I just downloaded it. So it's that easy, guys. It's really almost an afterthought, right? There's nothing to this. So you can get a free copy of SQL Server Express and you can do everything that I'm doing right here. So we're going to create Python code to convert to SQL scripts and then use these scripts to interact with the SQL Server database. Okay, if you know a little Python and you know a little SQL, this should be pretty straightforward. I'm going to show you step by step just in case there's something that you're not totally comfortable with or you don't totally understand. I'll show you step by step what to do here. So the steps for conversion are basically to understand the SQL script and what you want to do, map SQL operations to Python, translate the commands, and then handle data. So the first thing we're going to look at here is data definition language. If I go over here, I have another video on this, right? DDL versus DML, data manipulation language, versus DQL, which is data query language. Okay, you'll see the different types of commands over here. So data definition language is things like create, drop, alter, truncate, comment, and rename. Okay, data query language is typically what you would use, probably 90 to 95%, maybe 99% of the time you're using DQL. These are your select statements, and DML is insert, update, delete, these type of transactions, right? So insert is inserting data, update is updating data if it exists. You can do an upsert. Insert if it doesn't exist. If the record exists, do an update, that's an upsert. And delete is when you're deleting records from a table. You probably won't do too many deletes, especially in a production setting. People don't really delete things, right? You can get into a lot of trouble if you start deleting a bunch of data from your corporate database. But the common things are DQL, data query language. You'll use DDL in some cases, create, drop, alter, truncate, and DML is data manipulation language, right? So the first thing we see here is DDL. We are creating a table. So we have our driver, ODBC 17 for SQL Server. This is a server name, database name, and trusted connection equals yes. If I go back to the server, go over here, this is the server name. File connect will show you the server name. So you can copy and paste that into your code. Connect is right there. Cancel is there. And this is the database name, test. So you have server name and you have a database. So let me refresh this. If I go to test and expand tables right here, you'll see I have no tables, right? A system table, file table, external table, and a graph table. That's it, but there's no production tables here. So I'm going to create that. So I'm going to drop table if it exists. Create table. This is going to be a table name, employees, employee ID. The data type is a primary key. The name field is varchar 50. Department ID is int. Salary is decimal, right? So these are numbers plus cents, so dollars and cents, because we might not have a salary that is just pure dollars, right? We might have some decimal places, up to 2 decimal places, and 10 on the left, so it can go up to 10 figures. That's probably at least $1 billion. If your salary is $1 billion, you're safe. If it's over $1 billion per year, then you might have to go to a bigger data set like that. Okay, so that's all it is, and date. Then date. So we're going to create a connection. All this is going into SQL script. If I do Control F, SQL script goes down here after it's created here. We're going to execute the SQL script, and commit it. If everything's fine, we'll see DDL script executed successfully. If not, we're going to print an error, and we're going to try to go ahead and create that script and run the command and print connection closed. So we open the connection, close it. If there's an error, we'll see connection object not created. I think this is going to work because I tested it earlier today. So let's run it. DDL script executed successfully, connection closed. So let's go back to our database, refresh the view, control refresh, and see what we see. So tables, we have expanded this view, and we have DBO employees. Let's select what's in there. Probably nothing, right? All I did was create the table, and it's blank. So that's exactly what I told it to do, and that's what we'd expect. So DML, data manipulation language. So we're going to do the insert into employees, and then this is the field name, and some data. So here's the data relevant to all the employees. So open with the triple quote, close with triple quote again. We have the SQL script execute. SQL script goes down here, this line, and again we have some error handling. So if there is an issue, we can print the issue and understand what the error was, and if not, we will go ahead and do the insert, and then we'll get this message connection closed. And everything is successful. So let me run it. Insert, data insert successfully, connection closed. Let's go see what happened here. Alt A, Control F5 to run it, and exactly what we got is what we expected. So the data is inserted, employee IDs, department ID, salary, and hire date. And it all came from here. So again, we're doing Python to SQL converter. Here's all the SQL. We're using Python to convert to SQL into commands that we can manage in our Python environment. This is the IDE. This is a Jupyter notebook. So everything ran just like I expected it to. So DQL data query language, let's see what this does. Again, we have the ODBC driver 17 for SQL Server. If you don't know where this is, you can go over here, ODBC, Control Enter, and go down here for 64-bit, and it shows you your driver. Here's SQL Server, that's the name. And this is called, the driver name is driver ODBC, driver 17 for SQL Server. And if I this is all set up, so there's nothing to do here. If I had to set up a new connection, I would go to add and then just follow the prompt, SQL Server, and follow what it says. I'm not going to do that because I already have this. Data query language, I want to select all from employees. That's what I'm going to do. So before we had DDL creating the table, right? Just creating a blank repository to do the insert. Here is the insert. So this is DML, data manipulation language. This is DQL. Again, 90 to 95% of the time, you're probably doing DQL. You're querying the database. So I did select all SQL script. The SQL script gets executed right here on this line, cursor execute SQL script, and we are printing rows for row and results. Print row. So we're printing all the rows and closing a connection. So this is fine. Everything worked fine. Let's say we wanted to use DQL and put everything into a Pandas DataFrame. We could do that just as well. It's just a small change in syntax. Over here, we're just printing, right? We're printing all the records in that table, employees. That's what this is doing, printing. And then it shows you this message, connection closed. Let's say you want to push everything into a data frame and display the data frame. You would have rows over here, columns, rows equals rows, columns equals columns. It's always row, comma, column. In a Pandas data frame, Microsoft Excel does the same. It's always row, comma, column if you're doing some VBA program. So everything is pushed into a data frame, and then we display the data frame right here, and we actually print the columns over here. Print columns, right? And formatting, the little F over here means format, and then we are displaying the data frame. So print or display data frame shows you everything in the full data frame. And then if you just want to display the head of the data frame, by default, it's 5 rows. So if you leave it blank or if you put a 5, it's the same thing. So here's the entire data frame displayed. Here's the first 5 records, starting with a 0, going up to 4. Python 0 base, so you always start with a 0. And then you increment up to 5. 5 is actually 4 in this case. So let's say we want to read a CSV on our desktop, push that into a data frame, and then push the data frame into a table in SQL Server. So if you look at my desktop right here, so R. Schul, Ryan Schul is my name. I changed this recently, so it doesn't have my full name. It just has Ryan _ character. Probably I should change that at some point because that isn't too descriptive of the environment. It should be Ryan Schul, but that's the way it's named now. So at this point, we'll just leave it. I have this CSV file on my desktop. If we go look at it, this is, let me move that out of the way. This is all employees, and here's the data frame or CSV file. Here's the CSV file. I'm going to push this into a data frame and then push that into a table in SQL Server. Okay, so we have employee ID, name, department, salary, hire date, and then manager. So here's the new column. With manager, I'm saying David Williams is the manager here, and Chris Lee is the manager here. Okay, so that's fine. Actually, David Williams is the manager of Chris. So we could assume David is the CEO. Chris is probably the CFO, CTO, something like this. Obviously, it's a small company. There's just 13 employees here. Or actually, yeah, 13 employees, 14 rows because we have the header here. So that's the data frame. Let me close that. That's the CSV file. We're going to push that into a data frame and then push everything into SQL Server, right, in the table in SQL Server. So we're getting the CSV from the desktop, pushing that into a data frame. So it goes into file path, data frame, display the head of the data frame, and then try to push that into a new table in SQL Server. So we have df to SQL. Okay, so df to SQL is handled by this pyodbc. So again, we're using Python. ODBC connection was the connection that we saw before for SQL Server. Open Database Connectivity, I think that's what it stands for. That's been around for generations, pretty old technology, tried, tested, very true. So we create the engine, data frame to SQL. So data frame dot to SQL, we have the table name, connection equals engine, that comes from here. If it exists, replace, and index equals false. So if you want to identify everything or map everything to an index, you can do that. In this case, I'm not going to do that. I'm just going to say index equals false. Just go ahead and create the table, create the index on the fly, and do everything dynamically for me. Again, if I want to map to some pre-existing index, I can do that. If I don't want to do that, I don't have to do that. No module name SQLAlchemy. Okay, so let me go over here and see what's going on. We have the users, my environment. So whenever you're installing something, by the way, this is a good lesson to learn. Let me just deviate just for a moment here. We could do import sys, sys, and print sys.executable executable, okay, and control enter will run it. So we are in this environment in vires, enviz, okay, short for environment. My environment, so enviz and my environment, you want to make sure that this matches up with your Anaconda prompts, okay? If not, then you will install this and pip install into a different environment than what you expect, okay? So make sure my environment in brackets there, in curly brackets, matches this environment. If you have a different environment, when you do your pip install, you can get a message saying, okay, installed successfully. That's what you see here. But it would actually go to a different virtual environment, okay? So make sure you are working with the right environment. And then if we go Anaconda environment list, Anaconda environment, Anaconda, ANACONDA. Oh, that's not, let me go back here. Environment list. And list environments, Conda list environments. I never really bother memorizing these things. For me, it's not worth it. I'm more interested in doing things that are innovative and fresh and new and creative rather than memorizing things. So I tend not to memorize things. I just figure it out as I go. But sometimes it works to your detriment too, or then you have to Google everything, right? So my environment, so I have two environments here based in my environment, but look what you're using over here. I'm using my environment. So make sure this matches. Again, guys, if it doesn't match, go over here to kernel, change kernel. I know we're going off on a big tangent. So we have a few different environments, PyKernel, no kernel. You don't want that. You need a kernel, which is a memory placeholder. You want that. So again, just make sure that the environment that you're using matches up. Select that. My environment matches that environment right there. Control enter to run it. And it's running. We see the ampersand over here. And we see the little hourglass, but it's done now. So I am going to delete this, cut that. We don't need that anymore. And everything ran. Okay, so data successfully imported or inserted into all employees table. So we have this employee ID, name, department, salary, hire date, and manager. If we go back to SQL Server and do a refresh over here, right click, refresh, should see two tables under the tables view. Okay, and that is what we have: employees and DBO employees, all employees. This was the new one I just created, right? So if I select top 1000, you'll see the manager name over there. Okay, so mission accomplished, guys. We did it. We did exactly what we want to do. So we have the DML, the DDL, the DQL. Everything is laid out for you, nice and tight, very crisp over here. I tried to keep everything pretty short and pretty relevant. Okay, and I will share this code with you a little bit later today. When I post a video, I'll post all this code so you can copy and paste it into your own Jupyter notebook and run it. So what did we learn today? Let's do a quick recap here. Benefits of fetching data from SQL Server into a Python environment or Pandas DataFrame directly. Real-time data, dynamic querying, large data sets, data integrity. You don't get into the data, you don't touch it, you don't use your mouse or some other tools, right? You're just running code, very straightforward. The code will do exactly what you tell it to do. So you won't have errors, you won't have weird things popping up, you won't have strange disconnections or strange data entering into your space, right? So you have high data integrity, less disk space usage, and very flexible, okay? Batch loading, data transformations, validation, filtering, transferring, any kind of transformations, you can do that quickly and easy, and very simple, right? That's probably the number one reason that we use Python to SQL converter logic, like I'm showing you right here. Okay, so I'm going to post this video a little bit later today, and of course I will download this source code and share that with everybody as well. Okay, so there you go, guys. Pretty simple, pretty straightforward. Hopefully that was useful and insightful. Hopefully you learned a couple new tricks today. Okay, I'm going to wrap it up and I'll post everything later today. Check it out and check out my other videos. I've got about almost 160 at this point. I'm going to try to put out 365 videos in 365 days. I started on August 8th, 2024. Now it's January 20, 2025. So I'm about 160 days into my journey here of doing 365 videos in 365 days. Pretty much right on track, right where I want to be. Try to put out a new video every single day. So keep an eye out for that stuff. Thanks, guys. Take care and enjoy the rest of your day. Goodbye.